So, okay. So we're going to spend the next hour and a half just kind of talking about really architecting secure IPv6 networks. How many of you have IPv6 deployed? Okay. How many of you are going to deploy it within the next 6 months? Okay. Just want to make sure everybody's kind of in here. So just to let you know, I have updated this talk for the last 15 years. Okay, I started kind of when I started with IPv6 in 2004. Is that 10 years? Is it 20 years almost? Oh, is it? Okay, but whatever, since 2004, so I guess 11 years. But it's interesting because from a security perspective, right, the only thing that's changed is that people are paying a little bit more attention to it. And the key word is a little, right? But really, I know that last year, Eric Finke gave a talk on what's going on in IPv6 in terms of standards and best practices. So I'm going to talk about it in a little bit of a different way. And so what I want to do is cover, basically, I'll give a little bit of an introduction of myself, but then also talk about basic security requirements, right? And people never look at that. When they're deploying IPv6 networks, they just want to, make packets go via IPv6 transport and, make sure that nothing breaks in v4. But then they go, oh yeah, security, right? And that's really backwards. So I want to talk a little bit about that, and also how do you go about architecting a secure IPv6 infrastructure? A lot of people like to call themselves network engineers, right? The key word being engineer, and are you actually doing any engineering when you're architecting your IPv6 deployment, or are you just turning on features? And then just looking through, current best practices for securing IPv6 deployments, right? Looking at the actual device, the data, and then does IPsec fit in anywhere, and then some latest technology developments. So a little bit about me. I've been around for a long time. I started building backbones in 88, 89. Started using Cisco equipment very early and broke a lot of their equipment all the time, and so they hired me. And I ended up doing a lot of things. I started off with optical networks, then switching, routing. I used to do the internals of router performance and all that. And then in 96, 97, I've been going to the IETF since 1992. I came back to Cisco and said, hey, IPsec is going to get ratified. We should do something with security. So Cisco started their first security initiative, and they asked me to run it because I was always an individual contributor, and nobody ever thought that I would take their job away from them. So I had a lot of friends within the company and could actually bring people together. And that got me very interested in security. I ended up writing a book on how to deploy secure networks. And then I left Cisco in 2000, and for 15 years, I did consulting. And it was quite interesting because in 2004, I started doing consulting for various IPv6 deployments. And I forgot to mention that the other day, but actually in 2005, I was hired by Connections by Boeing, which was, at that time, they were providing the internet via their airplane. And my job was literally to be with 3 racks of equipment in the basement and work out their IPv6 strategy. And we had an IPv6 strategy, and then they ended up getting rid of Connections by Boeing because they couldn't figure out the appropriate business model. But I can very much state that I had the very first /48 private address being routed by NTT at the time, and this was in December of 2005. So I've done a lot with IPv6, really care about security, and so thank you, Enno, for inviting me to be here. So when we're looking at just security in general, right, I mean, a lot of these are just the basics, right? I mean, what are we trying to protect against? Some people go crazy and just say, hey, we need a security consultant, and guess what? Everything has to be 100% secure. Yet what you're trying to achieve, if something got leaked, it's more of an embarrassment than if you're, going to go out of business. So really, you have to do these trade-offs, and you have to do a risk analysis. And you have to think about, what are really the most important things from a security aspect. And I always say, let's go back to the fundamentals. So what do you really care about? You want to understand what the threats are to your environment. You want to understand where you're vulnerable. And then what is the actual risk to your business? right? These days, I'm a chief security officer in my company, so I have to get budget, right? And I have to, figure out where is the actual risk, what is the impact? Do I care about this vulnerability today, or is the impact so negligible that I'll deal with it when I have the time? And so really, you do have to think about, where am I vulnerable? What is the risk? And do I need to do anything about this? So, threats can come from a variety of places, right? There's protocol errors. We know this now with TLS, right? I mean, there's new announcements probably every 3 months, right, since May, about some new vulnerability that's critical. So protocols have errors, implementations have errors. Software bugs is a bug or feature, right? Some vendors are like, that was our feature, and you're like, no, that's a bug, fix it. Active attacks, right? These are happening more and more. I'm in a lot of security conferences where you know that there's state actors, there's criminal activity going on. So these active attacks 10 years ago weren't that great. They're pretty serious these days. And then, of course, configuration mistakes. And so if you fat finger something in routing, or you misconfigure a filter, right, that has the same impact sometimes as something that's been done deliberately, and you care about the impact. So you've got passive attacks, right, usually used for reconnaissance, sniffing on the wire. Hey, what can I see in terms of neighbor discovery? Where are the IPv6 hosts? Hey, what hasn't been plugged yet by the vendors? And then, of course, a number of active attacks where you're actively sending some kind of traffic. So if we look at what somebody can do, you can eavesdrop, sniff on the network. You can send arbitrary messages, right, IP spoof traffic, replay messages, modify them in transit, write malicious code and trick people into running it, right, your common phishing attacks, spear phishing attacks, and of course, exploiting bugs in software. So there's a lot really to think about. And when you're looking at your infrastructure, right, I show this picture a lot because I don't care in what environment you are, you've got components of all of that regarding whether or not you're big or small. If you're bigger, you just have more devices, right, and you probably have more of these clouds floating around. But you basically have the central portion that's basically the backbone of your network. That could be one router, 2 switches, it could be 1,000 routers, right, whatever your backbone is. And then you're connecting to various different places, either customers, your peers, other branches. And then, of course, you have the NOC, right, the folks that are responsible for your operations. And, sometimes it's in conjunction with your security operations. But the key point is, right, you have to look at all the devices, right, make sure all the devices are secure. So with IPv6, right, how can you actually secure everything in terms of how you get access to the devices? Then the data in transit from every single device that's speaking IPv6, and then, of course, also your network operating system tools and provisioning. So, again, I keep talking about, having engineering a security architecture. So you need to understand the problem. If you're deploying IPv6, right, what is the problem in terms of security, right? Where are you deploying it? Where are you using IPv6 transport versus IPv4 transport? And then also looking at, where do you have your security concerns? And typically, you kind of break it down to, physical access, logical access, the control or management plane, routing plane, and data plane, right? So these are very logical ways to think about, putting in some kind of security controls. And then also having procedures in place for incident response. And to me, that speaks a lot to the auditing mechanism, i.e. logging. And I'll speak a little bit about, the different logging and auditing mechanisms that we have. And this is something that I personally have seen in IPv6 needs a lot more work and attention. So these are the things that you want to keep in mind, right? You want to control the data access, the network access, making sure you protect information in transit. This basically speaks to integrity and confidentiality, i.e., your TLS or IPsec primarily. Ensuring that the network is available, making sure you can't be DDoSed. preventing intrusions, and responding to incidences. And the reason that I always kind of start with these set of slides is because security, the difficulty in security comes in because there's so many details, right? And over the last 10 years, I've loved all the new jargon that vendors come up with. And I'm always like, what is that? What's APT? You know, and I'm like, oh, okay, that just means that somebody's consistently trying to hack into you. Okay, whatever. You know, and whatever some other acronym is, you know, of the day, but I always bring it back to the fundamentals. You know, in the basics, what are people actually trying to do? And then really security is not that complex, it's just that there's a lot of details. And knowing where the details are that you have to look at, that becomes important. And I can't stress enough that you really have to compare your risk mitigation versus the cost of protecting it. And you know, people really do some silly things in terms of, you know, being more secure. And I'll tell you the story. I mean, years ago, I lived in Santa Cruz and I was trying to support this really small up-and-coming ISP. And they didn't have any encrypted access to their email servers, right? I mean, this was, in year 2001 or so. And it was interesting because I'd go to all these conferences. I have about 5 different email addresses, right? So I would use that one for personal stuff, and you know, I knew that anybody could have access to my emails probably, right, because it was all in clear text and everything. And I'm at a NANOC conference, and people came up to me and they're like, but you're a security consultant. I mean, do you know everything's in the clear? I'm like, absolutely. And I hope that somebody actually sniffs the password and logs into those email servers and does something, because then that company will get serious about security. I did a risk assessment. It's a win-win situation. Right? Nothing happens to me because all those emails, right, I'm like, they're emails that I know exactly, you know, if anybody reads it, I don't care. Right? And so it's funny the way people look at it. I'm like, you know, you have to assess the risk of what's actually going on. So I won't talk about that. So if you start looking at, you know, look at IPv6 and look at a kind of a security architecture there. You want to have primarily the same fundamental requirements for what you're trying to protect against, right? That's true for IPv4 and IPv6. But when you're starting to deploy IPv6, and some of you who have already deployed, but really, you know, think about some things here. You know, there's new protocol behaviors and new possibilities because of the extensive addressing. I very much dislike when people say, I want feature parity and I want to do exactly what I did in IPv4, because I'm going, really? So you want to do the Band-Aid solution, you know, that we did with IPv4 as it evolved, and you want to just continue with that? Right? That's not a good idea. So in some way, right, IPv6 was also created to have end-to-end communications. And, you know, if you think about IPsec, it was so you could have integrity and confidentiality from the sender to the recipient. Great idea, right? Well, everybody wants to do NAT, right? And everything else that they're doing in IPv4. So there's problems there. But is that something that you would want in your environment? Right? So where is NAT a realistic advantage versus actually a hindrance? And how do multiple addresses get taken into account? Right? With IPv6, there's multiple addresses per interface. So what does that let you do, or what's the issue there from a security standpoint? And then, of course, you need to keep up with all the components that are still evolving. It was interesting to me where whenever you pointed out issues that still needed corrections, people was like, oh, see, we can't deploy IPv6. I'm going, but that's the same with any other protocol, right? The routing protocol keeps evolving. What are you going to do, turn off BGP? You know? And so to me, it was, you know, we weren't being engineers in terms of figure out the issues, resolve the issues, find new issues, resolve those issues, and keep on going. And so to me, that was one of the hindrances, actually, of, I think, people really deploying IPv6. So if you're looking at, you know, how do you architect security? Well, fundamentally, right, what's the same for both IPv6 or IPv4 networks are the security properties and services, right? What do you want to protect, and what the properties of security? For example, you know, the integrity, the confidentiality, having authorized access. That all remains the same. But what's different for IPv6 architectures is that you've got the multiple addresses per interface, the protocol operation, i.e. Neighbor discovery and some other protocol nuances. There's more automation, right? That was done deliberately because at the time that IPv6 was architected, they were thinking that, hey, you know, all this, like changing addresses and all that takes a long time. Can we automate it somehow? Of course, now in practice, they found that some of that automation isn't really practical, but still, you have to think about it. Also, potential application integration. And what I mean by that is I was in an environment in 2007 where I did a security assessment for their IPv6 rollout. Yes, it was 2007. It was a very large company. And they were creating their addressing plan, and it took them a couple of months. And I'm like, what's so difficult about that? And they were like, well, you know, we want to look at a new paradigm because for addressing, you know, that ties into how we do our filtering strategy. And we want to keep our filters to a minimum. And our filters are application-based. So can you actually tie in some of how you're dealing with application into the overall addressing strategy, right? And you can't do that after the fact, right? You have to do that right in the beginning. And I actually was talking to somebody a couple months ago where there was another very large IPv6 only network that's being planned for, and they're doing something similar. So it's quite interesting to me. And then, of course, you know, there's the ever-evolving products. So you need to think about, you know, where is automation advantage versus a security risk, right? There's always a trade-off, ease of operability versus, you know, control, which is quite orthogonal. How will IPv content be accessible, right? IPv4 content is going to be around at least for a decade or two. You can't just say, oh, yep, sunset, let's turn it off. No way. So you always have to think about that and, you know, what's the best way of doing that? And the last point also, what security services are being used to adhere to the security policy requirements but are really instantiations of IPv4 architectural limitations. So I have to write security policies in my environment. And I have to think of, okay, so how are they practical? No, they're not 100-page documents, they're 5. Okay, and the reason that they're 5 is because the operational people have to know what they have to adhere to, right? And so some of these policies and even some of the compliance mandates that I look at, I'm like, okay, so some of these things are written because that's the way IPv4 was deployed. Is that necessarily an issue with IPv6, right? Most often, yes, and the one thing that I always refer to is NAT, because network address translation has become such a security feature for many who really don't understand why it actually came about in the first place. So I am not a fan of NAT, and you will hear that. So, you know, IPv6 automation, I think most of you are probably aware of these. So from the protocol capabilities, right, neighbor discovery was created so that it would allow nodes to easily create each other that are on the same segment, right? So automatically create addresses and find the neighbors. Also, router advertisements enable the nodes to automatically create their own globally reachable IP addresses. Again, this was so that users didn't have to get involved, you know, with hundreds of posts, but you could just, quote unquote, automatically create the addresses and, you know, create routable communications. Now, of course, the security issues are pretty vast, right? There's redirection attacks, denial of service attacks, spoofing attacks, and so on. So when you're looking at, you know, again, coming back to the architecture, right, you really want to think about your addressing and naming scheme. And really, you know, I've been in a number of different environments where they haven't really thought about addressing, and then later on, they had to actually go back and recreate their addressing plan because they realized that their filtering was getting so out of hand. And for anybody that, you know, has created, you know, firewall rules and all that, you know that you don't want to touch them. You know, you want to touch them as little as possible. And especially if you've got thousands of nodes in your environment, even if you have 5. Right? Because it's like one day you understand exactly what you're configuring, and then your brain gets kind of confused, right? Because you've got these 10 lines or 15 lines, and sometimes the ordering matters. And filtering is not as easy as it may seem, because you have to think about backdoors and backup traffic and all that kind of stuff. So easy in theory, but harder in practice. All right, the last point, okay, and this is the thing that I always come back to. Security is and always will be an afterthought. I wish it weren't, right? But as I've seen deployments, it really is. Because there's three things in my mind that you have to think about from security. Identity, which is the authentication and authorization. Integrity, right, meaning that you actually have some kind of integrity protection, either for your management protocols or your data protocols, knowing that I was actually the person that sent you the traffic, and then auditing, logging, and management. Confidentiality, to me, that's a policy decision. And I know that people are talking about encrypt everywhere. I always say it's a great concept in theory, but in practice, what happens if you lose your keys, right? Do you then not get your data again, right? And so I have nothing against confidentiality, but when it comes down to practicalities, I care about that more. All right, so getting back to the addressing plan. So that's the fundamental, right? You need to figure out what you want to do in your environment. And over the last 10 years, there's been various different scenarios considered. But for over 10 years, I mean, a /48 is the smallest allocation, right? That's routable over the internet. So in terms of what ISPs will filter on. Subnets are based on /64. There'll be probably for the next 100 years people saying that was a really bad idea. Yeah, probably, but something, that's what it is, right? A subnet is a /64. And then point-to-point links, there's an RFC that was written where actually the recommendation was a /120, 112. Some people thought, it should be a /64. More or less, most people have decided that you should use a /64 for your point-to-point links and then allocate /127s when you're configuring them. And I just saw a draft actually in the IETF that's being written to explain that. So basically what to do with addressing. And really when you're thinking about how you allocate, I mean, it's similar with V4. I mean, there are a lot of addresses, but keep in mind that, hopefully you'll have these around for the next, I don't know, 20, 30, 40 years. And so make sure that also, you're looking at your addressing boundaries and, have some space so that if, in case you allocated, one space, that you can actually have contiguous subnets depending on, your overall architecture. So, addressing and routing has worked for about 15 years. Really there's not too many problems. DNS and everything else is still evolving, right? Just keep that in mind. So with DNS, a lot of the issues come from, when do I get an A record versus quad A record with, happy eyeballs. That gets quite fascinating these days, depending on the implementation. And then what's evolving are really controls for layer 2, layer 3. They're still evolving because there's still issues in terms of spoofing and potential denial of service attacks. So the IETF is working on things, vendors are influencing certain work in the IETF, or they're trying to come up with their own functionality. But just keep in mind that these things are still evolving, okay, which is okay. And I'll show you in detail actually what some of these new protocols are. And also the monitoring and provision and the application and content and what they do. Transition technologies. I remember when I got involved in IPv6 security, it was 2004 because I was living in Venice Beach at the time in California, and there was an IPv6 conference in Santa Monica. And at the time, I think there were 33 the kind of shim6 technologies that were being discussed, 33 different proposals. Over the last decade, there's been a lot of different transition technologies that have been discussed, these have been standardized. Some are being deprecated, just because when an environment found that, hey, you know, they wanted to go to IPv6, and they realized that they still had to support IPv4, and how do you do that? Sometimes they figured out what was easiest in their environment, and then that became an IETF proposal for a transition technology. So, you know, 6.4, Teredo, ISATAP, NAC 6.4 were basically the first couple that were thought of that, hey, you know, this might be a good idea. But then later on, as people were doing actual deployments, there were other ones such as DS Lite, 6RD, carrier grade NAT, and NAT 444. I will say that I worked for Connections by Boeing, as I mentioned earlier. In 2006, we had a strategy to actually turn the ground stations, the 5 satellite ground stations, to do IPv6, and our decision had been to go native. And the reason why is because when we looked at the operational costs from a people and personnel perspective, and what would it take to actually get to the native v6 that eventually you wanted to get to, it was much better to do that immediately than to work on some transition technologies and then go to that later. So that was just that decision that was made at that time, and I was actually part of that group that created that strategy. And I actually still believe today that if you can, think about going native v6 sooner rather than later. So dual stack Lite, a lot of people are trying to utilize it, you know, some with better success than others. And basically, it's trying to help build an IPv6 only native infrastructure. It assumes that you have an IPv6 network and enables you to tunnel IPv4 over it. And the premise is that your network is primarily IPv6, but that the service is primarily IPv4. So it's something a lot of people are using. In some conversations I had yesterday, they said also that, yeah, I mean, people are finding that it's so hard to run that basically, and the problems that they're having, that it's a forcing function for folks to now look at native v6 better. And I'm going, yay, you know, it's a good thing. 6RD is something that also has proliferated quite a bit, and it tries to help with building a dual stack infrastructure. In France, Free.fr provided an application that only ran on IPv6, and it actually came up with an IPv6, IPv4 tunnel infrastructure that could provide that service. And that's one of the reasons it really took off. It's IPv4 plus IPv6 over IPv4, and the premise is that the service is an application. So in the talk, I'm just listing a bunch of different transition technologies that people are utilizing. DNS 6.4 and NAT 6.4 is also being utilized by some folks. But really, in my mind, right, when you're looking at transition technologies, think really carefully about what you need in your environments and whether or not you can go to native v6 sooner rather than later. So, I was always wondering, before I really got into IPv6, why are people talking about security being built in? I mean, you know, I go to the IETFs, I keep hearing the hallway conversations, and then I never heard about security being built in, but, you know, when I'm outside talks to going to the conferences in 2002, 2003, I kept hearing the security's built in. And then one day I was like, all right, let me see what this is all about. And so it's about these 3 things. So at the time that IPv6 was being architected, there was some well-known fragmentation attacks. And I don't know if it was LANC or Smurf, you know, one of them was broadcast, one of them was fragmentation. But it was one of those attacks that, you know, was pretty widely known. And so the engineers were like, okay, we gotta, you know, make sure that in IPv6 we handle fragmentations better. So, you know, so they prohibited, in the standard, it's prohibited to have fragmentation by intermediary devices. Overlapping fragments are not allowed, and devices must drop reassemble packets that are less than 1280 bytes. this is what the standard says. That doesn't necessarily mean that's what implementations do, right? Just reality check here. Also, there were the broadcast attacks, right? Again, I think it was LAN-C or Smurf. I always get the two confused. But so in IPv6, they removed the concept of dedicated broadcasts, and there's also specific language in the specifications to avoid ICMPv6 amplification attacks. Okay, and I think that was actually the Smurf attack. And then the biggest reason that they talked about security being built in was because the standard mandated that IPsec be implemented to be IPv6 compliant. Now, back in 2004, 2005, I saw a lot of IPv6 implementations that did not have any IPsec implemented, right? So, okay, so they weren't standards compliant, but so what, right? People were still trying to deploy IPv6. And so really, you know, the myth around, hey, deploy it because it's more secure was a fallacy, and it's too bad because, you know, then when people found out that, well, it's not really secure, so why deploy it? Right, it caused this whole issue in terms of, well, why are we deploying it anyway? And then address depletion obviously became the forcing function. So, you know, but you do have to think about security. Security is not automatically built in. So, all right, how do you start, right? And I had a couple of consulting gigs with IPv6. And the first thing that people always told me was, help us architect a secure IPv6 network. Number one rule, don't break anything that exists. Yes, we know it's terrible. Yes, we NAT everywhere. Yes, we're using address space that's not ours, but we know that it'll never get announced. Right? Those of you in large ISPs, you know that's, you know, everybody does this. And also, right, they said, don't re-architect the current problems and place limitations on IPv6 capabilities, right? So, I mean, these are the two fundamental things. And really, you know, you have to think about, you know, what is best for your environment in the future for your network to actually get the operational ease better. Because a lot of IPv4 networks have tunnel over tunnel over tunnel, which is kind of awesome when it works, and really terrible when it breaks, right? And so my litmus test on a good network architecture is when something breaks, how quickly can I fix it? Because it's supposed to work, right? The problems come in when something goes down or there's an issue, so how quickly can I fix it? All right, so you're going to deploy IPv6, right? You turn on IPv6 enable. What else do you do? Right? And a lot of people don't think about actually securing their device, right? If it's secured with IPv4, you need to do the same thing with IPv6. To me, that's not feature parity. That's just making sure that you're putting in the right controls for, you know, securing access to your device, right? And you also have to secure the management plane. And, you know, this gets overlooked in IPv4 as well. And so with IPv6, right, and with a lot of different denial of service attacks that are now coming to the surface with NTP and a lot of other protocols, you know, we have to be better at protecting them. And so you have to put in the mechanism either via some kind of access list control or rate limiting, right, for these types of protocols. And so this is true for both IPv4 and IPv6. Can't even begin to tell you how many environments I've seen where they decide to, you know, slowly get the operational folks used to having IPv6 in their environments, turn on IPv6, and put no controls in for their SSH access. And I actually did that by accident also in my home router. And I had IPv4 go down, and I was at a conference somewhere, I'm like, oh yeah, I can get in via IPv6, you know? And I was like, okay, but this is bad, I should really put in a filter. I was happy that day, you know? However, right, I realized that, hey, you know, I keep telling people about putting in filters, I need to do that myself as well. And so, you know, you really have to look at it. The thing that I always find interesting, though, is that you have different syntax usually for IPv4 and IPv6, and that hasn't really gone away. So you can't just replace your IPv4 syntax with IPv6, which means that your scripts also will have to get updated. So SNMP. We had a talk on this yesterday, actually by Gabriel. He's in the other room. But he gave a really great talk about the status of MIPS in IPv6. And basically, right, the realities are that even today, IPv6 MIPS support is randomly available. Okay, it depends on the vendor, it depends on the platform. SNMP over v6 transport is also not always available. But the realities are that most management is still and probably will be done using the IPv4 transport. And then, you know, here's the common best practices. It doesn't matter whether or not you're in v4 or v6. So one of the things to note about MIPS in an IPv6 environment is that years ago, when first the standards started creating standards for IPv6 MIPS, they did it so that there was an IPv4 MIB already. They created a totally separate IPv6 MIB. That has changed over the last years, and now there's protocol version independent MIBs. Okay, so they apply to both, whether or not using v4 or v6 as a transport. And some of the latest ones are listed here, the IP forwarding table MIB and MIB for IP. As was depicted in the talk yesterday, where Gabriel actually walked through different Juniper and Cisco devices and Brocade devices, support is random, right? And so really, if you're looking to do any kind of SNMP support with IPv6 devices, then you really do want to look at doing an SNMP walk to really understand what's supported, because sometimes the documentation is ambiguous, and while it says, hey, this MIB is supported, you will find that not all variables are. So, sorry, you do have to actually check this. Also with SNMP, right, can you actually utilize IPv6 transport from the agent to the collector and the collector to the viewer? Right, that's not always the case. So you really have to figure that out on a vendor-by-vendor basis. And then viewers, do they support IPv6? So another thing to look out for when you're doing an SNMP walk, that the syntax is actually different from IPv4 and IPv6. For IPv4, you can just put in the IP address. For v6, you have to specifically also put in the UDP6 colon, and then the IPv6 address. And in some cases, you also have to specify the protocol port number, the 161. And so I did a couple of searches recently on the internet just to see for different devices. And so the top ones for Linux, the SNMP set, and then there's also SNMP walk example for Cisco. But you can see that you have to have the UDP6 and the IPv6 address in there. And this actually happened in one environment. This is also something to look out for, and this speaks to the knowing which address is being used from the interface, you know, for the source. And so in this environment, right, they created global unique addresses, and then in their router, in the filter list, they explicitly, you know, allowed the global address through. Well, it turned out that the actual SNMP server used the EUI64 address as its source address, so it was denied at the router. Right? So you actually have to look at what do actually applications do, right? Which source do they pick? So it makes IPv6 quite interesting. You know, you learn to use Wireshark really well. So logging, people love and hate logging. Right? You always want to log enough information to be useful but not overwhelming, and you want to create a backup plan for keeping track of logging information should the syslog server be unavailable. And of course, the one thing I always ask is, are your timestamps synchronized? And people are like, huh? Right? And so, yeah, when SIM devices first came out, that was the first thing I asked them. I'm like, so how do you ensure that the logs are synchronized, right? Timestamps. They're like, oh, well, we just make that assumption. I'm like, okay, that's great. So people buy these, expensive devices, but they might be just throwing garbage at it, right? Because how do you correlate logs that, where the timestamps aren't synchronized? So these are the fundamental simple things, right? But you have to think about it. So when you're looking at logging, right, and auditing, can you actually listen, using these protocols, using IPv4 and or IPv6 transport, right? It's not just a given. And I'll give another example. So, I didn't know this, but 6 years ago, I was giving a talk at a NANOG on IPv6 security. And I had that slide up as your timestamp synchronized, right? And I had this woman in the audience who was actually the area director, I think, or no, she was the working group chair for NTP. And in her queue was the document that would actually standardize NTP over v6. And she said, it's been in my email queue, and you shamed me into finally looking at it and sending it off so it be ratified as a standard. And this was like 5 or 6 years ago, right? And so I was like, oh, I didn't even realize that the standard wasn't yet ratified for NTP over v6. And so it was kind of interesting to me. So when you're looking at the auditing and management functionality, right, you have to actually ask that question, is it supported over v6 transport? Because it's not a given. There's a lot of deployments now and larger companies who are making the requests of the vendors, and so that's a good thing. So the problem always has been that the vendors are asking for the customers to do something, the customers are waiting for the vendors just to do something. You got to talk to each other. Netflow also. Netflow, you have to use Netflow version 9. And I had some side conversations with people yesterday who are deploying IPv6, have just made some larger deployments, and are just this week starting to deploy Netflow version 9. Okay, I gave a Netflow version 9 talk in 2005. I remember this because I was in Kyoto, I was in Japan. And so, because that's when I first learned about Netflow version 9. It's 10 years later, right, and there's many environments that still don't have it. To utilize Netflow in an IPv6 environment, you have to move from Netflow version 5 to Netflow version 9. And I did a quick look on tools. Actually, most of the commonly used tools support Netflow version 9, like NFSend, NFDump. They've done that for years, and some other ones also. So let's look at some of the common kind of theories and what's done in practice, again, to secure IPv6 networks. So when you're looking at addressing, right, the theory was always from the standardization aspect that, you could use static addresses, but really stateful auto configuration is probably what most people use, and sometimes also stateless auto configuration. Privacy addresses, of course, were created because everybody wants their address to be private. And then there's that continuous controversy between router advertisements versus using DHCPv6. And I'm not sure that's ever going to get resolved. It's kind of like a religious war. So we all know that there's multiple addresses, right, that are required on a host. So you have a link local interface, any assigned unicast address, the loopback address to all nodes multicast, the solicited nodes multicast, and any other multicast addresses for a group. And I did this on my Mac yesterday just to kind of see, like, hey, okay, what can I see? And I was surprised because I'm used to seeing a, the FFFE, the link local address, and a global address. I'm like, what the heck is this third one? Because I was looking at the routing table first, the netstat command. But then, on the ifconfig, it's like, oh, yeah, okay, here's a temporary address. So they keep adding newer ones and more. And I'm going, all right, so when I do some traffic, when I have time, I'll do some traffic analysis and just kind of see which addresses is being used for what. But this scares me a little bit, right? Because again, I don't know what applications are going to use, right? So you got the temporary address, you know, different privacy addresses and you know, your link local and all that. And so now there's more addresses that an application can use. And also yesterday, because I hadn't tested this, and it was really interesting to find out that there are some operating systems where if they use a privacy address, they don't time out. So all of a sudden you have 50 of them, right? So that's kind of interesting. So really in practice, right, what people do is they define static addresses for anything that's really critical. So privacy addresses, I mean, they're used by default by, I say Vista, but it's really by Microsoft. But for me, I don't have anything against privacy addresses as long as I can correlate the information to a log, right? I'm a security person. When an incident happens, I want to know who was responsible, right? There's malicious malware somewhere. I see on the network that the traffic exists. Well, which host is sending it? And so as long as you can correlate logging information and know which privacy address it is that corresponds to certain log entries or certain, you know, behavior, I don't care what address you use. Okay, but I've also found that DHCPv6 is used in a lot of environments exactly for this purpose. I want to know which device had which address when. And that's specifically so that you can correlate any kind of information when something malicious happens in your network. And so there's that trade-off in terms of, do you want to know which machine it was that sent something versus, yes, absolutely, I want to know. And NAT is always a fascinating topic. I really kind of gave up in terms of trying to convince people that NAT was not a good idea when I learned that there were 6 separate implementations on the market that did NAT6 to NAT6, right? Which is not standardized, but they actually, you know, translate an IPv6 address to another IPv6 address. And I said, okay, you know, people will do whatever they want in their deployments. My recommendation will always be to not utilize NAT when it's not necessary, right? And that just varies. With security, there's best practices, but you have to look at which best practice apply to your environment. Okay, this should be pretty familiar to a lot of people also. You know, how does a node get initialized and what are all the automated things that happen that from a security perspective, right, you want to be aware of and where are the potential vulnerabilities and attack vectors. So, you know, in theory, you've got this trusted router. It sends a routing advertisement so that, you know, the host can create their own globally accessible address. And then you have neighbor discovery, right, also, so that hosts know who they can communicate with. And in theory, you had duplicate address detection, send in CGA, privacy addressing, and then also filtering mechanism that would provide all the protection. Now, in practice, you really have to think more about how do you avoid spoofing, denial of service attacks, how do you avoid overriding caches. Right, that was a huge issue in the beginning where people didn't think about the fact that, wow, okay, you know, somebody could really overload the cache memory and oops, you know, switch no longer available. And, you know, does MAC filtering make any sense? Typically not. It's more of an overhead and a burden. I mean, maybe for your critical devices, but usually not. And so one of the things also, it's getting better now over time, but host behaviors have to be understood. And send in CGA, I don't know of anybody that's utilizing them. And I still keep track just in case, but it was interesting to me because I think the router vendors were the ones that actually implemented send, yet the hosts don't, right? Microsoft doesn't. And you would think that somebody like you know, a host operating system, they're the ones that most require that. So I've been kind of stupefied by that. And of course, there's more layer 2 mitigation techniques that are needed, to avoid spoofing and denial of service attacks. So, this is just an overview slide in terms of anybody that doesn't know what SEND is. Basically stands for Secure Neighbor Discovery. And it's supposed to protect against spoof messages, right, to create false entries into a neighbor cache, dealing with neighbor unreachability detection failures, router solicitation, advertisement attacks, and so on. But it doesn't protect against a few other things that, some people thought they would provide confidentiality. Nope, not at all. It also doesn't compensate for any, insecure link layer. So there are things that it can't protect against. But like I said, Secure Neighbor Discovery, SEND, I know of nobody that's using it. Anybody here in this room? Yeah. And so there's still work going on the IETF. I'm going to be there next week, and I'm curious, just, maybe somebody in the government, the don't ask, don't tell is using it. I have no idea. But I still follow it because you never know. In concept, it's interesting. In practice, wait and see. So, but these are issues that are more fundamental and practical right now. So, better router advertisement and DHCPv6 filtering. And so most people that have deployed in larger environments have actually, been speaking to vendors to create specific solutions because they have that need in their environments. Rogue RA and DHCP servers are a reality. So right now, networks with visitors that use either router advertisements or DHCPv6 for address assignments will have the exact same problem if somebody comes along with a rogue server, right? So basically, they're asking for features that limit where RA messages and DHCPv6 messages can be sent from. So specifically, allowing the router advertisement messages only from routers and the DHCPv6 responses only from DHCPv6 servers. There's also some Ethernet equipment that has the ability to filter on Ethernet source and destination. So only allow messages to the router's multicast address to go to the switch interface that have routers on them, and only allow messages to all the DHCPv6 servers' multicast address to go to the switch interfaces that have the DHCPv6 servers or relays on them. So these are specific feature requests that were actually requested a couple of years ago. And so there are vendors that actually have this functionality in them. And then, of course, there's these specific layer 2 security mechanisms, AreGuard, DHCPv6 guard, IPv6 neighbor discovery inspection, and then also SABI. And all 4 of these are to get better control over the layer 2 traffic. Right, and to be able to help out with either spoofing or also denial of service attacks. So one thing that was interesting is that AreGuard is mostly a Cisco feature. Yes, it has been standardized. I know of at least one vendor that will never implement it, and it's because of the way that the licensing is, the contract is by Cisco. And so, I don't know whether or not any other vendors have implemented it. And this was like a year ago that I talked to this one particular person who worked for another vendor. So I don't know, I think other vendors are doing things that are probably AreGuard-like. I like router advertisement guard. I think it's a really good idea and has some really good functionality. So folks should at least look at it if you have Cisco devices. Filtering. So security, to me, a lot of it deals with access control. Right? So filtering is a huge part of that. Filtering is something that most environments do really poorly. Right? And also, when you're troubleshooting any kind of an issue, the first thing that many operational teams do is they take off the filters for the interface. Because you're trying to troubleshoot why isn't the packet getting from point A to point B, what could be the problem, and you take off the filter to see if that's causing any kind of an issue. Right? I've seen this often enough that I know this is absolutely true. And then sometimes people forget to put the filter back on again when they realize that no, it's actually a DNS issue or whatever else the issue was. But really, we need to be very cognizant of the filtering and the filtering strategy, which again ties sometimes to the addressing plan that you have for IPv6. So this is actually a configuration that I have at home. Obviously, I'm showing you the documentation, address. But I do have a /48 at home, and this is the configuration that I have. Because I only want to allow what's in my home test network, right, out to my upstream provider. I don't want to send them garbage. And so in many small businesses, right, whether or not you're V4 or V6, you should be putting anti-spoofing filters on. Too many people do not do this, right? But if you have a prefix, you have a subnet assigned to you, and you're not a backup path for anybody else, or you don't utilize anybody as a backup path for something, then this is just something we should all be doing and recommending, to everybody else. So general firewall, best current practice, right? And this does not deviate from V4 or V6. You want to explicitly deny all traffic and only allow what you need. You should do this. In some environments, it's very impractical. Okay. Do not rely on your firewall for protection of your network. I've heard some people say, let's get rid of firewalls altogether, right? And some people like the firewalls. There's never a one is better than the other. We have to use all the tools that we have available. And so to me, a firewall is at least the first line of defense to protect yourself against silly traffic that you should never see. So I don't have this pointer in this particular slide set, but I talked about it yesterday. There's a RIPE talk that Jen Linkova from Google did. And she actually did some research in terms of IPv6 addresses that you should not see on the internet, yet there is traffic that with those source addresses. How they're leaked, who knows, but they exist. And so again, to me, that means that the filtering isn't done, right? And these are just very simple filters where you're just denying source addresses from an IPv6 address that you really shouldn't be forwarding. So here's some ingress IPv6 packet filters to consider. And again, the ones that I'm showing you, right, these are the source addresses that if you see them, they should never be propagated on the internet. Obviously spoofed, obviously, hopefully just from a test network, who knows. But, to me, it's just, stopping the propagation of silly traffic. And, these are some additional ones. And also reject the packets which have your own prefix in the source address field. I mean, these are simply sanity check filters. And in my mind, really equipment vendors could have these on by default. There's no reason why you have to configure them. Or, they could just have a template where you just say, yep, put, silly spoof filters on. And so these just show slides where you can, for what's relevant. You guys, I think, all know this already, but because of the Smurf attacks was it Smurf? Or Lancea attack, sorry, that's the one with the ICMP, issues. A lot of people started filtering all ICMP in their IPv4 networks, which is just silly, right? Because you want to ping routers. And so they started doing that with IPv6 too, because you have to have feature parity with IPv4 and IPv6. And this is where they did not understand that you needed to have certain ICMPv6 packets, right, for normal IPv6 operation. And so you have to be cognizant of what they are. And I have a slide on what they are later for those of you that aren't familiar with ICMPv6. So for more things to consider with the ingress IPv6 packet filters is, and this one's interesting, deny sending packets that use the routing header unless using mobility features. Now this was routing header type 0, okay? Now there's also a routing header type 3, and then there's another routing header that is being standardized by Cisco that really deals more with software-defined network environments. And so there are folks that want to deprecate extension headers, yet there's more extension headers that are getting created. And really, what we need to make sure of is that vendors have functionality where you can specifically filter out specific extension headers and possibly even specific types. And I'll get on that a little bit later. Things like 624 and Teredo aren't really being utilized that much. They were implemented maybe 10 years ago or so, but it turns out that they cause more harm than not. And so people are actually starting to deprecate. So these are the ICMPv6 types that you absolutely need for IPv6 operations. So you need the type 1 code 0, the no route to destination. You need certain types for path MTU discovery. So in my recommendation, right, don't filter on specific types. It's just too onerous. I mean, figure out another way to try and avoid any kind of denial of service for ICMP traffic. Because filtering it looks easy, but it's actually hard when you're trying to maintain them. So, you know, or you can have a code block that just says, okay, here's all the ICMP specific filters, right? But also look at how good are the operational folks in your environment. Like, what I've learned is that it's really easy to say, well, why aren't these people doing that? Why aren't they doing BCP38, you know, ingress filters for spoof traffic everywhere? And then I get into an operational environment, I'm like, oh, interesting, okay. That device has an issue, you know, you put in 2 filters and, you know, there's a bug, and so, you know, the router reboots, and, you know, here's another issue, and here's another issue. So everything is real easy in theory and makes sense, right? But in practice, it's a different story. So if you can, right, then be specific in what you filter, so even ICMPv6 types. But, you know, for ease of operations, sometimes I would just avoid filtering ICMPv6 entirely. What I was alluding to earlier, we need better IPv6 extension header filtering. And especially, you know, the currently defined extension headers are listed here on the table. So the hop-by-hop option, the routing header, fragment header, ESP and AH are for IPsec, and then destination options. And here's why for the routing header, right, this was a problem. And this came out in about 2006. And it was a big enough problem that within a year, the IETF started the draft and finalized the standard. Okay, so it was very quickly done. Everybody understood this was a problem. And so it became RFC 2460. And basically what it says is that, you know, the routing header is used by an IPv6 source to list one or more intermediate nodes to be visited on the way to the packet's destination. Each extension header should occur at most once, except for the destination options header, which should occur at most twice. IPv6 nodes must accept and attempt to process extension headers in any order and occurring any number of times in the same packet. That's already funny to me, occurring any number of times in the same packet. So what would happen is when you have a routing header of type 0, right, it may contain multiple intermediary node addresses, and the same address may be included more than once in the same routing header, which means that you could have a scenario where you could have a amplification attack where, you know, the route bounces between, the packet bounces between A and B multiple times. Okay. And so once that was discovered, right, this could easily be exploited, they decided, okay, this is really a bad idea, so until we come up with something better, let's deprecate the routing header type 0, because we know that source routing is not recommended in IPv4, so why are we even doing it in IPv6? People couldn't come up with a good answer, and so they deprecated it. Eric Vinke yesterday gave a talk about basically source routing in IPv6, this new type of routing header, but they've also thought through how to avoid this issue. Okay, so evolution, right? So anyway, so when this routing header issue came up, right, so they thought that, okay, we can disallow processing, but still allows all other hosts to be used for attack. So dropping became the requirement for ISPs. And then RFC 5094 was the deprecation of the routing header 0. That's right, so, oops. Right, so the RFC 2460 just talks about how do you actually increment the extension headers. And then RFC 5095 was the deprecation of the routing header type 0. But one of the things that people had to recognize that you still had a routing header type 2 that was used in mobility environments. So really, you couldn't always just point blank drop the routing header. So it was interesting because, different vendors, I have the Cisco example here on the slide, but depending on which version of code you're running depends on how much granularity you have for actually dropping the routing header. So prior to 12.2.15t, you could only filter out the entire routing header, whereas later upgrades, you can actually filter on the routing header type 0 specifically. But not every single equipment allows you to do that. So again, it's equipment specific and vendor specific also. And so this is something that we do have to be aware of, because extension headers, there's a lot of controversy about should we continue to use them. There's actually some work being done to research how much filtering is being done on extension headers. So ISPs are filtering on them, largely for fragments. But there's this thought that, hey, can we do away with extension headers? Because also they're the biggest problem in terms of operational IPv6. Whenever I go and ask somebody, hey, do you, a vendor that deals with security, and they say, yep, we support IPv6, my litmus test for whether or not they really know what they're talking about is, what do you do with extension headers? The only question I have to ask. And depending on their answers, when they say, yep, that's a problem, I'm like, you get it. When they're like, extension headers? I go, okay, give it a couple of years. Yeah, because this is the problem, right? I mean, extension headers make, it's purely a performance issue, by the way, right? I mean, extension headers, processing them in ASICs, variable length, very difficult, right? So usually you punt it up into the CPU path, and so that slows everything down, right? That's the fundamental problem. And so what's going to happen in the future, I have no idea, right? I mean, we need fragments. I would like to think that people will still utilize IPsec, so it's, let's see. But be aware that this is something that we need to keep on the lookout for, because people can bypass security issues by doing clever things with extension headers. And you'll get these slides. So these are just some recommendations, and I've used these all the time. in terms of looking at, what you can do. I actually last night changed the one from Team Cymru because, I want to make sure that all these pointers are still all valid. So, Garrett, I see that yours still is. I double checked. Because some of these are old. The one from Garrett is like 10 years, 15 years, something like that. Yeah, but it's still valid, right? And then Team Cymru used to have this nice template for bogons. Well, they have a service, right, where you can get the bogon IPv6 routes through, their BGP announcements. And so rather than creating templates, whatever, they now have a new reference where they just give the reference and then also point you to the service that they provide, which is a good thing. So one thing that was interesting also to note is that you have more IPv6 reserved addresses. Right, and so I just looked the other day, and I wasn't familiar with ORCID here, so I'm actually going to see if I can read up on that in the next couple of days. But there's a couple of addresses that were added here, in the discard-only prefix and stuff like that. So in terms of IPv6 reserved addresses, right, you do want to keep up with what some of the latest developments are. And this is purely in my mind so that you can, add to your anti-spoof filters. So BGP prefix filtering, again, this is also the same for IPv6 and IPv4 networks. And, the problem in most ISPs is that people are not filtering comprehensively. They're filtering their customers' prefixes and filtering prefixes going out of their network. So we all have to get better at filtering. I gave a security one-day talk 4 years ago, and my every third word was filter, because my first question was, so how many of you are running big networks? How many of you think you're filtering effectively? Nobody raised their hands. And I said, I'm going to get you guys to filter because filter. I'm going to be so annoying, filter, that you're going to filter. And I literally did this for about 5 minutes. And one guy raised his hand. I was in Japan at the time, or Taiwan. And he goes, ma'am, if we promise to filter, will you stop? Yeah, and I decided to trust them. Yeah. But I did have a couple of people actually come up to me at the end of the day and show me some of their filtering, and we actually talked about it. And even if 1 or 2 people continue to be better at this, I'm happy. But we really do have to think about filtering a little bit more often. You will find that these particular examples look very much similar to the packet filters that I showed. Okay? And at times, right, you have to think, do I want to actually create packet filters and apply them to my interface? Or is it much better if I don't have these things in my routing table? Right, so it's sometimes a trade-off depending on what granularity you have or wish to have, or what's better to be implemented in your environment. But we want to make sure that any of this illegitimate traffic, is not propagated. So here's a couple of the v6 prefixes to consider in terms of your anti-spoof filters. Your own prefix. The 6-bone is no longer utilized. 6-4 also is getting deprecated. Teredo. And then always look at the newer developments. Okay, like I just pointed out in RFC 6890, there are about 3 or 4 prefixes that were added in the last 3 years, like ORCID and a couple of others. So as there's new developments in the IETF, they'll come up with new specialized use addresses, and this is true for IPv4 as well as IPv6. And sometimes they get depleted from the special use addresses. So this happened to me with IPv4. Right, I've given a lot of basic security workshops, and there was this RFC 3330 that only dealt with IPv4 reserved addresses. And there was one talk that I gave, and somebody pointed out that, wait a minute, this address, it was a test IPv4 address, it was actually reallocated to be used, to actually get used. And so I had talked to Bill Manning, who was the original author of that RFC 3330, and he said, oh yeah, I need to update that. And so it turns out this RFC 6890 is created specifically for both IPv4 and IPv6. and that has the latest as to about a year ago. So these are things that you do have to monitor. You know, reserved addresses are not just static. And this just shows a configuration example. And I do this because sometimes people just cut and paste, right? You really shouldn't do that. So I didn't add some of the newer ones on there. Okay, and this is something, I had a breakfast conversation with somebody this morning where he said, yeah, before I give my slides out for the troopers to, you know, actually post them, I'm going to put the 2001 DB8 addresses instead of the addresses that I have on there, right? And that is good practice. I mean, that was specifically created because of the fact that people do, they cut and paste. You know, they cut and paste, put it into their configurations, and they cut and paste crazy stuff. They cut and paste example passwords. When I kid you not, that's why you have a lot of this, you know, Cisco One, or I have a book that I wrote, and I put password as let me in. I thought it was being funny, right? And this is, you know, 1999. I didn't think about it so much. There's a lot of let me ins, you know, around, and I'm going, oh, I hope that wasn't my fault, you know. But people do, they literally cut and paste. So when you do examples, you want to be careful about that also. People used to filter on RIR allocations. Okay, when IPv6 was first getting deployed, that was probably a good idea. Now, I think we've gone to the side that if you do that, right, there's just going to be so many new allocations that you won't keep up. So keep that in mind. And so this was something that people used to do in terms of here's their current allocations. It needs constant updating. I only put this in here as a, this used to be best practice. It is not anymore because you will not keep up. So I would steer away from that.
I made a count that this to sound like anyway. But probably those people in the room who have a different opinion. Did you notice that there was strict filtering? Yeah, there was like a, can you go back a slide? No, that one. This sounds familiar to people here in the room. Like only accept prefixes from that space, which is the the current most used right from PA allocation space once it's greater or equal than 13 and lesser or equal to 32. This is a so-called strict filtering.
Yeah.
There's a huge debate about that, which I'm going to cover in my talk at the end of the day.
Oh, okay. Cool. Didn't know that.
Yeah, as I said, there's a debate about if this is a reasonable approach or not. So.
Yeah, and I think, you know, strict filter.
What you mentioned about copy pasting the stuff, I think one should be really aware what one is trying to achieve when applying things.
Yes.
And be aware of the consequences, as I know Phil pointed out in detail.
Yeah, because most people really don't think about the operational consequences, right? And the fact is that, you know, filters, it depends on your environment, right? If you're in an environment that you have to be stricter and you have very good operational teams where they're cognizant of that and keep up with that, great. But there's other environments where you create a filter and you just do not want to touch them, right? Unless there's like an absolute emergency, right? Which happens if you have 1 million devices, right? I mean, I've been in those environments. And they say, think about your filters carefully because once they're there, it's going to be a huge amount of effort to get anything changed. And that's because of operational issues also. You change something, every time you change something, you risk that you make a mistake and, you know, something happens. So I put this slide almost in every IPv6 talk just because I want people to do anti-spoof filtering and get better at it. And so, you know, the decision is where do you do it, right? Do you do it at the ingress to the router, which is the BCP38? I always say that I don't want people talking about BCP38 anymore because it's a specific case. And even Paul Ferguson, right, who I actually work with, and who I know extremely well, he's a co-author of BCP38, he doesn't talk about BCP8 anymore. He says anti-spoofing filters. And so I've long been a proponent of doing it at the egress, so as close to the source as possible, of where you could potentially do spoofing. And then, you know, really anywhere that you could, just put in anti-spoof filters. And as you can see, the configuration isn't necessarily difficult, especially in some smaller enterprises, right, or home routers. And I've been a huge proponent of seeing whether or not equipment vendors can actually do this automatically in some way. Like just learn what the actual prefix is that you're using and then create that filter to only allow traffic out with the source address of that prefix. Or rather that subnet. Okay, so I already talked about why people started talking about, you know, why is security built into v6, which obviously is completely wrong. But I'm going to talk a little bit about IPsec. I happen to really like IPsec. I think it's very much misunderstood. OpenVPN, yay. And I think, you know, the vendors created a lot of this issue. So back in 2005, I actually decided that, you know, this is a really great opportunity to get IPsec done right with IPv6 because there aren't that many shipping products. And I can easily say that in 2006, 2007, I knew 10 or 12 of the biggest implementers. Okay, we're talking Microsoft, IBM, and you know, Cisco, Juniper, and who have you. I actually knew all of them because I talked to all of them about this. Let's get IPv6, IPsec done right, have common defaults, and let's fix the issues that make it so difficult from an operational perspective. Because the interoperability problems were mostly not technical issues, they were configuration issues. And sadly, that never quite happened because the vendors, while they kind of agreed, I was the only one asking. I had no money. You know, I was just saying this is the right thing to do. And you know, they were waiting for customer input. And so, you know, customers don't really necessarily ask for IPsec. And so that didn't happen. But let me just give you a little bit of a quick, you know, point of view here. Because I think with all the TLS issues, and there are many, right? I mean, every 3 months or so, we hear of an update. Right? There's another vulnerability. At the IETF, they're having these conversations about, you know, what do we do about TLS? Should we come up with something else, right? And then it's like, well, you have IPsec. So you never know if all of a sudden people are going to get more interested in IPsec. So one of the biggest issues with IPsec, right, which is why TLS became so easy, was how do you bootstrap credentials? Right? Now, you could do the same thing with IPsec, where you have some a priori trusted, you know, certificate chain there and roots. But in my mind also, it's becoming quite interesting because you have these manufacturer-based certificates and all that. So as long as you have some a priori trust relationship, right, then IPsec could become as easy to use as TLS. And it could be useful for any slew of things, right? Any kind of integrity and confidentiality between different applications. But what you really need is interoperable defaults. And the window of opportunity has been closing. So this is a thought experiment, and this is probably too small sort of for you guys to see. But I had written something up in 2006 that actually a friend of mine sent to Vint Cerf, just to kind of see what the thinking was. But you know, there's too many things going on, and I wasn't really pushing it. But my thought was also always, if you could use IPsec, right, for integrity protection of traffic from sender to recipient, would you be able to do any kind of reconnaissance scanning attacks? Right, because reconnaissance and scanning is how most attacks happen. They want to see what's vulnerable, they send some packets and, you know, get some information back. If you actually had integrity protection, then what would end up happening is that those packets would get denied and you wouldn't get a reply. So the attack vectors would change, But I thought that, well, everything that's happening today starts mostly with reconnaissance, or a lot of it, I shouldn't say most, but many things. So if you could stop that reconnaissance from happening, right, would that make a difference? So just a thought experiment, you know, conversations to have over beers. But here are the vendor-specific deployment issues. There is a lack of interoperable defaults. So I used to have this conversation with engineers all the time, the ones that were coding, you know, IPsec for varying vendors. And like, well, we don't want to mandate a policy. I'm like, it's a default. It's like the default timers or buffer settings on a router. You know, nobody's going to really mess with them unless they're really, you know, there's a real need. And so think about what the default should be, because you're all the security experts, right? You all go to the IETF, talk to each other, say, hey, this is what we think is the best, right? You have algorithms that you say are, you know, must have and others are recommended. So create that default, right? I'm certain it meets the requirements of at least 80% of the population, and the other 20 will learn how to change them. There's also configuration complexity. I was on a panel in 1998 on is IPsec too complex? I was working at Cisco at the time. And I said, yep, the standards is complex, but for the user it shouldn't be. Yet for the user it is. Because most vendors use jargon that is ridiculous. Right? What is mod P? Huh? What's DH? Do I care about Diffie-Hellman? You know? I've actually met with Diffie, you know, nice guy. But, right, I mean, when you're configuring something, I want to know, is there authentication? Is there integrity? And do I use a key or a password? That's all I care about. Mod P, now I got to, like, you know, do some Google searches and figure out what the heck is that. And let's see. So with IPv6 and IPsec, right, are enough people aware that IPv2 is not backwards compatible with IPv1? Does anybody use IPsec? Yeah. But with IPv6 or IPv4, it's really the same, right? Except that the IPsec people didn't know IPv6, and so they were surprised, oh, you mean you don't just have an address, you have to wait to get an RA and then you create the address? So there was some work that they had to do to actually take that into consideration. But that was fixed, oh, I don't know, 7 years ago. But the thing is that IPv2, that's my first question with vendors. Are you shipping IPv2? Because most people still use IPv1. IPv2 has been a standard for at least 8 years. And the biggest issue here is that if you decide to go IPv2, right, then it's not backwards compatible with IPv1. So I've decided that I'm upgrading to IPv2. I try to initiate a connection with Garrett. He's got IPv1. It's like, now what do we do? And so vendors have done their own way of downgrading to IPv1, but it's not standardized. Right? And so that gets fascinating. OSPF v3, right, mandated that you use IPsec because it's IPv6, and you know everything in IPv6 has to be protected with IPsec. The fascinating thing was that it didn't say how. And so when most people did integrity, they did AH. Well, AH is a should or a may, whereas ESP, right, the encapsulating security header, which does your encryption, is the must. So for those of you that may not know, AH is the authentication header. Oh, I have descriptions on this. I'll show that to you in a minute. So I'll describe what AH and ESP is so that you have more of an idea. But there's a couple more things you have to think about, also PKI issues, right? And PKI issues, I mean, this is true everywhere. What certificates do you trust, right? There's compromises with CAs. How does IPv1 or IPv2 handle certificates? Most of that now has been standardized, but again, you have to see what do the implementations do. However, I will point out that TLS also, while people used to say, oh, it's simple, you don't have to think about it, I think everybody in this room by now knows that's not true, right? I mean, it all depends on the implementation, and implementations do have issues. So here's the thing. So with ESP, let me see if I have AH. I don't, okay. So what AH does, right, it provides integrity checking throughout the entire packet. So from the header to the end. And the only thing that's not included is the fields that can change during transit, right? So your IP addresses and some options and all that. But integrity is throughout the whole packet. So back in 1998, there was an interoperability test with IPsec, and people realized that, oh, wait a minute, AH doesn't go through NATs, right? And so they realized that, wow, we have to do something about that. So they created something called ESP null. So ESP, encapsulating security header, was really defined to do confidentiality, but then they also added integrity so that you could do integrity only. Or rather, it did confidentiality integrity, but you could only use it without the confidentiality portion so that you could have integrity without, and the integrity is done for everything except for the IP headers. Right? And some people, there's this controversy, is that good enough? It is good enough. So when you actually do an analysis of what gets protected with AH, there's immutable fields, right? And so really the fields that get added for integrity protection for AH are minimal compared to what you have with ESP. And I would love to have an offline conversation with people to, you know, if you want the details. But the problem with ESP is that it's very difficult to tell whether or not a packet is just using integrity, which means that, you know, your firewalls, IDSs, and all that can actually look at the traffic, or whether that's encrypted. And the reason why is because that information is way at the end of the packet. So I don't know if you can see this, but so basically it shows what happens in transport mode or tunnel mode for IPsec, for ESP. And so you have the ESP header that's added, you know, in between your extension headers and TCP, but you've got this ESP trailer. And in the trailer is the actual information about integrity protection versus confidentiality. So if you're thinking about, you know, an ASIC device, right, it only goes so far into a packet, well, you don't know whether or not it's encrypted or not, right? And so that's been a problem. And so this actually shows you, you know, the authentication data, the ICV, and that it's all the way at the end of the ESP part. So the IETF actually came up with a solution to this, which is called WESP. I can't remember what the W stands for. But this way, it's actually easier to be able to process the packet early on and be able to tell whether or not it's integrity protected or encrypted. And just as a kind of trivia fact, right? Anybody know why they created AH versus ESP? This was, it wouldn't be relevant today, but this was back in, remember, this was started in the mid-90s, and there was still government crypto import-export restrictions. So with authentication, right, it didn't matter how long the key was, but with encryption, it did matter. Right? In the US, you couldn't export anything to certain countries that were more than 40-bit keys. And so they decided to make that difference between just the integrity, right, the authentication part, versus the actual confidentiality crypto part. So that if you were to export, then at least you'd have really strong integrity or authentication technology. So that was really why AH versus ESP was created. So there was an actual reason. Yeah, so here's some of the issues with the vendors, right? And those of you that have ever looked at IPsec, even tried to do it between 2 devices or 3, I mean, to me, this is really ridiculous, right? You have 3 different vendors, and they all have different, you know, default settings. And the one that I really, you know, bothers me the most is the group ones, right? This speaks to the mod P, the Diffie-Hellman. And really what that is how do you authenticate, you know, the initial exchange to authenticate the 2 peers. What the heck is group 1, 5, or 2, right? I know that it's, you know, how long is the key size? Is it 768, you know, 124, 2048 bits? But it tells me nothing, and this is what you see in the configurations. I mean, some of them have gotten better, they've gotten more automated, But this is basically the default. And then this gets even more fun, right, which speaks to actually the terminology issues. So, for IKE phase 1, you can say IKE phase 1 SA, IKE SA is a KMP SA main mode. It all means the same thing. And so somebody that doesn't know the standard, and you say main mode configuration here, and is a KMP SA here, you're like, huh? Right? How do you know that that's, the same thing? Same thing with Diffie-Hellman key length. It's either called DH group, mod P, or group number. And then IKE phase 2 has 3 different terminologies that different vendors use. So in my mind, right, this is not a technical issue whatsoever. It's just purely terminology, but it makes it difficult for people. And, well, they just say, forget it, TLS is easy. Just real quick, this was, in my mind, right, you do authentication. Why couldn't IPsec configurations look like this? Looks exactly like MD5 authentication, right, for BGP, and then have everything underneath work the way it should. And I did an interoperability test with Procket when that was still there, Juniper and Cisco with the real big boxes. And it was real interesting because Juniper actually did stuff under the cover. It was so easy. I could do that kind of the BGP configuration. The problem was that you had to pay extra money to get an add a pick. And then Cisco, of course, was, had really interesting configuration. I worked at Cisco. I talked with the engineers. It was the most roundabout configuration I have ever seen. I mean, just logically to me has never made sense. I mean, yes, but no. And yeah. So, and you'll see these. I'm not going to read through them. But these are what I would recommend as taking a look at in terms of the latest in terms of security functionality, right? For CBE devices, I mean, lots of back and forth in terms of what should be the basic requirements. Some of the latest with router advertisements, neighbor discovery. Send and CGI, again, nobody's using them as far as I know, but I still keep tabs on it because somebody is still developing, right? At least from a standards perspective. Cisco has it implemented. I think Juniper has it implemented. But to me, the key point is, these host devices. This one here, where they're still in draft stage, I would take a look at these documents. And I will do a little bit of advertisement here. That very last one, I'm a co-author with Eric Vinke on that one. And we're trying to finalize this next week. We basically consolidated about 80 or 90 drafts. You will see a lot of different RFC references because we wanted to put everything that had anything to do with IPv6 security and put it into one document as a best practice. Okay, and the last I looked, it was like 80 or 90 RFCs that we're trying to consolidate. So it's a pretty good synopsis. So as a summary, I don't like the word defense in depth, but yeah, layered security, right? Look at what's under your control and try to mitigate the risk as much as possible. And some basic principles, right? Make sure that address assignments are performed in a reliable manner and cannot be spoofed in whatever way that makes most sense in your environment. And make sure that malicious behavior can be detected, right? I care a lot about auditing and management detection because I want to know about anomalies, right? Again, my role is as somebody that is responsible for security, right? I want things to deploy efficiently, but I need to know when something bad is happening in my network. And these days, there are a lot of targeted attacks, and any one of us can become a target for who knows who. Okay. You have to harden the host, right? And this is true for IPv4 and IPv6. Do not forget about filtering when you're enabling your IPv6. Right? Make sure that you provide some restrictions in terms of who can access your device and from where. And also protect traffic between hosts. And as I said before, I'm all about encrypting everywhere, but remember key management. And the issue I always raise that at least if you have integrity protection, which to me is more important, I want to know that if I'm sending you something that you know that it came from me and that nobody's modified it in transit. To me, that's much more important than the confidentiality aspect, right? Some things should be confidential, but not everything in my mind. And if I lose the key or something happens to the credential that can decrypt it, what's going to happen, right? And so these are operational considerations that we have to think about. And so as a conclusion, right, a lot of these things that I pointed out, they're true in IPv4 and IPv6. People sometimes just forget to include some of these mechanisms for IPv6, the protection mechanisms. You may need to modify your security policies. When regulations say you must have NAT, I always say, why? Right? What is the fundamental security protection where you think I should have NAT? Because maybe in an IPv6 environment, I do not want NAT, so what else can I do? And critical, identify actual versus perceived risk, right, when deploying cryptographically protected services, and keep credential management in mind, right? And there is actual risk versus perceived risk. If there's a vulnerability, it may not apply to you, right? You have to look at it. Questions? And I know I ran over. Sorry about that.
Yeah, that's not much of a problem. Thanks.
So.